Alright, so today we're going to look at solving radical equations and ones that have rational exponents. So we're going to talk about all of this. Before we do anything, let's kind of look at the steps. So we've already seen radical equations when we were graphing them last time. So we did start graphing last class. It looked just like this. We had the square root and we had the cube root function. The whole point of us solving these is because we want to see what values we're going to be able to find. We want to understand what x's we can locate on our graph without actually looking at the curve itself. I want you to keep in mind, because there's something we're going to have to do when we're solving equations that you probably don't like to do, and I apologize. Remember how your x for your domain for your square root graph is only going from all of the numbers that are greater than 0? Yeah, that's going to create what's called extraneous solutions. Extraneous solutions, you probably haven't seen it in a while, is whenever you have an x or an x value that you solve for that doesn't exist. So we're going to see what that looks like today. Cube root functions don't really have that issue because their domain goes from negative infinity to positive, so there's no restrictions. What we're kind of doing with solving is we're trying to see if any of the restrictions from your graph come up. So let's go ahead and look at the steps, like I said. So with the steps, there's a few things you're going to have to do. First step is you're going to need to isolate your radical or exponent term. Once you isolate, you're going to have to square or cube, depending on the index, both sides. You're going to solve for x, and then, like I said, you're going to need to check for extraneous solutions. I know it sucks, but you're going to have to check. One thing that I want to remind you guys of over here is whenever you're doing even roots, if you're solving an equation that has even roots, so something like this, if I gave you x squared equals 4, you would square root both sides and get x equals plus or minus 2. Anytime you take the square root or fourth root or sixth root, any even root for both sides of an equation, you must include, your plus and minus symbol. You must include that plus and minus symbol. Let me actually rewrite that a bit. Whoops. Must include your plus or minus symbol. When you solve this, we got plus or minus 2 at the top. That's what we want to make sure we include. For the odd roots, anytime we do an odd root, so like the cube root of some number, the fourth root of some, or fifth root of some number. So for instance, if we had x cubed equals negative 8, and we cube root both sides, cube root of negative 8, we saw this last class, is going to equal negative 2. There's no plus or minus, it's just negative 2. So whenever you're doing the odd root, you're going to use the sign of your radicand. And I already know somebody's freaking out. Wait, Miss Tapia, what is a radicand again? We talked about this last class. Whenever you're looking at a radicand, when we were talking about simplifying radical expressions, radicands are the items underneath your radical. So that's what a radicand is. It's the item underneath your radical. So let's go ahead and try to solve a few. One last thing, forgot about this, that I want to add in. Whenever you're solving and you have, for instance, negative 2i, or negative 2 and you're taking the square root, you want to make sure that you use imaginary numbers, which I put a capital I. This needs to be a lowercase I. You need to use the lowercase I when you're taking the square root or any even root, so 4th, 6th, 8, any even root of a negative number. You always want to include that I. So it seems like a lot of things that we're talking about, but these are all things we've already talked about before. I just want to make sure you don't forget them. We're going to solve a few questions today, and after we solve, we're going to be done. So let's go ahead and start out by looking at example 2. So go ahead and look down your page. Let's look at example 2 to start off. All right, for example 2, the first step says to isolate. So, Caitlin, what should I move first to isolate everything from this radical? What can I move?
Minus 1.
Okay. So this is going to give me the square root of 3x minus 8 equals 2. Let me ask you again. Is the square root isolated? There's nothing in front of it, nothing behind it?
Yeah.
Is there anything in front of it? Anything behind it? No. Okay, so we're good. We're pretty much isolated. The second step at the top of the page says that you need to square, cube something, both sides. Let me just double check really quick. Caitlin, what's the index on this radical? I don't see it. 2. It's an imaginary 2. You don't have to put it, but understand that this is a square root. What's the opposite of square rooting? What's the opposite of square rooting, guys? Squaring. You're just squaring both sides. So we're going to make this 3x minus 8, the square root and the square cancel, and it's going to equal 4. All you need to do from here, guys, is solve. This is just algebra 1. The only algebra 2 part was remembering that opposite of square rooting is to square something. Once we have that, we're just going to move a couple things. We're going to add 8 to each side. And then we'll divide both sides by 3. So down here at the bottom, x will equal 4. Lorraine, am I done? Look at the steps at the top. Am I done? What else do I still need to do? I need to check for extraneous solutions, which I'm just going to label as CK. We're going to check. Guys, when I say to check, and I've already seen people today be lazy about it, take the entire original problem in black, and you're going to plug in this 4 for x. So we're going to have the square root of 3 times 4 minus 8 plus 1 is going to equal 3. All right, let's go ahead and simplify. This guy over here, let me zoom this in over here. We're just simplifying using PEMDAS. We're not isolating, we're just simplifying. So I'm going to go ahead and square root. We're going to do 3 times 4, which is 12. 12 minus 8 is going to give me 4, plus 1 equals 3. And the square root of 4 is just 2. Keep in mind, guys, the reason why I didn't put the plus or minus, I'm not solving, I'm just simplifying. When you simplify, you do not have to put the plus and minus. So from here, I'm going to go ahead and add. What's 2 plus 1? 3. What do you notice about both sides of this equation? Are they the same? Yes. Since they're both the same, your solution, which I'm going to put in the solution blank, is going to be 4. That should be your solution. All right, let's go ahead. Same process. We're just going to look at question 3 right underneath. It's a little different because it has a cube root, but we're still going to be able to solve it. Chris, what's the first thing I should probably do? Add 24. That's a good start. Let's add 24 to each side. So we're going to make this 8 cube root of x is going to equal 24. Okay, so let me ask Chris this. So guys, look up for a second. Chris, what's the next step you could do? Divide by 8. So guys, don't write this just yet. I want to give you some options. You could divide by 8 first. You're absolutely right. Will 24 and 8 reduce, Chris? What's 24 divided by 8? 3. So we could rewrite this as the cube root of x equals 3. You can definitely do that. The other thing that you can do, and this only works when you have rational functions, at least this is what I'm going to tell you guys, when you have rational or radical problems, at this step, instead of dividing by 8, you could actually do the opposite of cube rooting here. What's the opposite of cube rooting? Cubing. You would have to raise it to the 3rd power. So you can do one of 2 steps here. I'm giving you the option. You can either divide by 8 like Chris just said, or we could cube both sides. But here's the thing. If I asked you to do the cube of 24, what's 24 times 24 times 24? Do you know that off the top of your head? No. So that's why I'm saying work smarter, not harder. If you try to solve it this way and say, oh, I don't know what this cube of 24 is, don't do it this way. We're going to do like Chris did. We're going to divide both sides by 8 first, because 24 divided by 8, once I can write the x correctly, is equal to 3. That's going to be a lot easier to find the cube of instead of 24. So I'm giving you options. You're going to see that later on where you'll have an option to do this cubing step first instead of waiting. And we just said this. The opposite of cube rooting is to cube, right? Chris, be careful. Please don't tell me 9. What's the cube of 3? So 3 times 3 times 3. 27. This should be your answer. So let's check it. We're going to talk about more options that you have later on, guys, but let's go ahead and check this for now. Take this original problem that is in black, and I want you to plug in that 27. So 8 cube root of 27 minus 24 equals 0. We are just simplifying using PEMDAS. You are just simplifying using order of operations. So this radical is kind of acting as a grouping mechanism, at least that's what some textbooks say. So, Chris, we talked about this earlier. What's the cube root of 27? 4. Or not 4. 3. There we go. I was trying to write 24. That's why I said 4. And then, Chris, 8 times 3? 24. And 24 minus 24 is just 0. Do both sides of this equation match? Yes. So that means that 27 is going to be your solution. So let me highlight that, and I'll go back and highlight the other one as well. So 27 over here for my solution will be my answer. That's my solution. Give me a nod or shake. Is this okay so far? All right, cool. Let's look at number 6 on the next page. All right, question 6. Okay, this one looks a little disgusting. It has a rational exponent. So this is when you have an exponent that's a fraction. It's okay, we'll make it work. All right, first thing I need to do is try to isolate. So if I was to try to isolate this rational exponent, I need to move the 6. So let's go ahead and subtract 6 on each side. So we'll have 3x raised to the 1/2 power is going to equal negative 6. Nicholas, how could I rewrite this 3x raised to the 1/2 power? How could I rewrite it? Square root of 3x. You're absolutely right. Square root of 3x. Really quick, Nicholas, what's the index on this radical? 2. And what's the exponent underneath? Technically, all of this is raised to the first power. We already said this. It's understood if it's a square root that there is a 2 that sits as your index. You don't have to write that every time. And anything that's raised to the first power, again, you don't need to write. All we did, guys, and Nicholas is just remembering what we did a couple days ago when we looked at rational exponents. This guy. When we talked about rational exponents, this is exactly what we talked about. So all of this stuff, guys, is coming back to fruition right now. All right, so let's go ahead and finish this up for question 6. We have the square root of 3x. Okay, that's great. Nicholas, how do I get x by itself? I still need to do some things. What can I do now? We probably should square both sides. That'll get rid of that radical. So when you square root something that's already being squared, that cancels. So you're left with 3x equals, what's 6 squared? 36. And then from here, we'll just divide both sides by 3. So x is going to equal 12. Just 12. Am I done, Nicholas? What do I still need to do? You have to check it, guys. I know it sucks. It's not fun, but you have to check it. So we're going to take 3 times 12 raised to the 1/2 power plus 6 should equal 0. I'm going to give you guys a head start. Try to simplify it. You are simplifying using order of operations on the left. All right, let's see. We have 3 times 12, which is 36, correct? Plus 6 equals 0. Brooks, what does it mean if you're doing 36 to the 1/2 power? You're square rooting. Yes, you're square rooting. I did have somebody last class ask me, can you just take 36 and take half of it? No. This is not what this exponent means, guys. You can't just create math. That's not how this works. You have to take whatever the exponent is, and you need to write it as a radical. So I'm going to rewrite this as a square root of 36 plus 6 equals 0. Brooks, what's the square root of 36? Just 6, positive 6. When you add both of those, Brooks, what do you get? What happened? What's wrong with this? It's not the same. So that means what's going to happen to 12? What is it? It's an extraneous solution. So EXT, I usually label that as extraneous. You can't use it as your solution. So, unfortunately, correct me if I'm wrong, we only solved for this x, right? There was no other x that we solved for? That's the only answer we had. So since this is the only answer we have and it's extraneous, we're going to put over here for our solution, no solution. This is a no solution problem. I'm going to add in something. You guys know how your homework's on Delta Math, right? So on your homework for Delta Math, for some reason, for the questions I've selected, it won't accept no solution for an answer. I tried writing it several different ways. If you type in no solution for the answer for any of your questions, it's not going to give you credit, but you're right. So instead, what I need you to do is I need you to write, instead of no solution, You need to put those little brackets. Not even joking. Just those brackets, nothing in the middle, no zero, no number, and that will accept it as a no solution answer. So write that bracket in Delta Math. And that's only if you have a no solution. For some reason, it's the only thing that it accepts.
I really quickly want to interrupt your video just to show you how to put your answers in on Delta Math if you do have homework assignments on Delta Math for this. So I know this question, I've already solved it. I know it's a no solution. So if you get a no solution for this, what it will not allow you to do is actually type in that little curly bracket. So the bracket we were talking about on your notes, it won't let you type it in. It said instead to press the plus or minus button to add or remove solutions. So if you were to add solutions, that would mean you would probably have 2 solutions for this question. For this one, I'm telling you now, I've already solved it. This is a no solution. So what we want to do is we want to remove every single answer choice that it could possibly have. As of right now, this is 2. As of right now, this is 1 solution. If you hit that subtraction sign one more time, it's going to pop up with the brackets like I told you in your notes. So you're just going to go ahead and put these brackets, which will represent a no solution. And that will give you the credit. So as you can see, both of these answers that you solved for were not true, which is why this is not a solution.
All right, we have our no solution stuff for Delta Math understood. This is only if your homework is on Delta Math. For question 8, this is our next one. Okay, let's solve question 8. First thing I need to do is isolate the x with my exponent. We're going to subtract 11. So x to the 2/3 power is going to equal 16. 3/2. We just saw this on the other page. We can rewrite this as a radical. The cube root of x squared. And that would equal 16. Okay, let's take a second and look up and let's think for a second. What's the opposite of cube rooting? Cubing. You would have to raise it to the 3rd power. Think logically, guys. Can you take the cube root of 16? Or excuse me, can you cube 16 in your head? 16 times 16 times 16? No. You can use a calculator, but I don't want you to have to use that, just in case I don't give you a calculator on your next quiz. Is there a way for me to rewrite this so I don't have to cube first? Is there another way for me to rewrite that radical without having to cube first? Say it again. To the power of 2, but where would 2 be? Underneath the radical or outside? Outside. This is your other way of writing it, guys. I want you to understand that you can write your radicals one of 2 ways. This way or this one. This method is definitely usable and ideal for questions like you're about to do with number 8. The reason why is because you won't have to do 16 times 16 times 16. And it'll prevent you from making a mistake. When you have larger numbers, you're more prone to make a mistake. So let me rewrite what we're going to use instead. So for question 8, down here at the bottom, we're going to rewrite this as the cube root of x, but outside, instead of underneath your radical, we're going to put the squared. That means we're going to have to get rid of the squared first. What's the opposite of squaring? Square rooting. So we're going to square root all of this and square root this. I wrote this on the first page. When you square root both sides of your equation, what do you have to put? A plus or minus. All right, we'll keep it. Not going to like it, but we're going to keep it. What's the opposite of cube rooting again? Cubing. So you're going to cube both sides. So I'm going to have x equals, we're going to keep the plus or minus. You're going to have the same 2 answers. What's 4 times 4 times 4? 64. Same thing if you did positive 4 times 4 times 4, or if you did negative 4 times 4 times 4. You're still going to get a positive and negative 64. What does this mean? It's 2 solutions, so do you just check one? You have to check both. So I'll split the work with you guys. You guys check negative 64, I'll check positive. So you guys do this check step for negative 64, I'll check positive. Remember, we're checking to see if either of these have an extraneous solution. So don't just say, oh, I don't feel like doing it, I'll just look at Miss Tapia. No, try it yourself first, and then I'll confirm it with you. All right, so I went ahead and I solved for positive 64, guys. I rewrote the squared outside of my radical because if I put it underneath, I didn't want to do 64 squared in my head. That was not going to work for me. So what I did was I took the cube root of 64, which was 4. I then squared it, and then I added it to 11, which gave me 27. So for one of your answers, you do have positive 64 as a solution. You guys tell me, is negative 64 also going to be a solution? Yes, negative 64 will be a solution. If you simplify it, you will get 27 equals 27, and they're both positive. So both of the solutions that we have, positive and negative 64, you could write it as plus minus 64 or write it as two separate numbers, positive 64 and negative. Questions? So now that you guys have finished question 8, before we move on, I want you guys to try to do on your desk right now, question 7. So either do it on your desk or in your notebook on this paper, but I want you guys right now to try to do question number 7. So I've looked around, you guys did really good on this. So yeah, for question 7, you should have gotten positive 5 over 2. If you checked this, this worked out as a solution. So yeah, 5 over 2 is your solution. I'm going to write that here, 5 over 2. It is okay to have a fraction as your answer. On your homework, it'll probably ask you to write it in decimal form, which is okay, or fraction, doesn't matter. But on my tests and quizzes, guys, you already know, I want to see it written as an improper fraction. All right, we only have a couple of other things to look at. So right now, I want you guys to flip your paper over to question 10. So go ahead and move this over to question 10. We just have a couple more to look at. All right. Question 10, ew, this one looks a little gross. First thing I want to try to do is isolate everything from my square root. Let's try to see if we can move everything from this radical. So first thing I would move, Omar, what should I move first? The x, let's add x to each side. So 3 square root of x plus 1 is going to equal x plus 1. And what would I do from here, Omar? Divide. Okay, so before you guys divide, hold on. We would have to divide this, this, and this by 3. I'm just thinking ahead, so don't write this just yet. Omar, after that, you would have the square root of x plus 1 equals x over 3 plus 1 over 3. What would you have to do from here? What would you have to do to get rid of that square root, Omar? You'd have to square both sides. Still, don't write anything just yet. I just want you guys to think ahead. When you have this binomial squared, what am I going to have you do? Say it again, Lorraine, but a little louder. You would have to FOIL. Let's be 100% honest. Do you guys want to FOIL with the fraction? That's why I told you guys not to write. This is one option. If you actually FOIL this fraction, you'll get the correct answer, but I don't want you to panic with the fraction. I don't know if y'all remember, what was the other method I said y'all could do instead? If you didn't want to divide next, what could you do next? Not multiply. You can square it, not square root it, but you could square both sides. From here, you could square both sides. This is a lot easier for you guys to see compared to dividing. Omar is absolutely right. You could definitely divide and then have to FOIL. But I don't want you guys to FOIL with fractions. I don't even FOIL with fractions. So what we're going to do is we're going to actually multiply this 2 times. Okay, well when you multiply this 2 times, it's just going to turn into 3 squared, which is 9. And then the square root of x plus 1 times the square root of x plus 1 is just going to turn into x plus 1. You don't have to FOIL that. All of this is one big term. So I'll say that again. Look up for a second. All of this in this first radical or first parentheses is all one big term. All of it. Is this all one big term? No, these are 2 separate terms. So for this part here, just like Lorraine told me earlier, you're going to have to FOIL this. So we got a lot of distributing to do. In the first parentheses, we're going to distribute the 9. And in the second one, we're going to have to FOIL. Please don't mess this up, guys. 1 times 1 is not 2. It's just 1. I wrote that first period. I'm going to combine my like terms. All of this is Algebra 1, guys. And we need to solve. So Desiree, how am I going to solve this? What should I probably do? I already did that. Okay, so move. So what am I moving into what side? Okay. Both of them, right? Let's subtract both of them. I think since y'all are almost at the end of Algebra 2, I could do this. We're going to combine this all into one big step. So that way we don't have to keep rewriting it. Yep. So we're going to have 0 equals x squared minus 7x minus 8. How would I solve this? I'm going to have to factor it. So let me refresh your memory, because your homework tonight is probably going to have a few different methods you can use. So over here to the side, let's write out some methods to refresh your memory. The methods of solving that you can use, and I'm going to put my little asterisk next to it. We just said factoring. We can definitely do that. What's another method we learned how to do with quadratic equations? Quadratic formula. That's a U. Quadratic formula. Anything else? Completing the square that you guys don't like. Anything else? Oh, that's ironic. Y'all love using it on tests and quizzes, but y'all never use it right. The square root method is the last one. You only can use the square root method when you only have an x squared as your variable. That's the only time. So if you want to write parentheses, only when you have an x squared. That's the only time you can use it. That's the only variable. Just when it's an x squared. All right, you guys told me factor. Y'all can factor. Factor that. Go ahead and factor. All right, so we're going to go ahead and factor. So underneath it, I need to find two numbers that multiply to -8 but add up to -7. So the only two numbers I can use are -8 and +1. Since your leading coefficient in front of x squared is a +1, you can write both of your binomials. So we're going to make this x minus 8 and x plus 1. Both of those are equal to 0. So we're going to set x minus 8 equal to 0 and x plus 1 equal to 0. I'm going to add 8 to each side. So x will equal 8, and I'll subtract 1 on each side. X will equal -1. These are your two solutions. Right now, you guys need to check. Make sure both of these solutions are actual solutions. Double check your work with mine, guys. You should have two solutions. And really quick, guys, be careful with this negative that you plugged in for -1. It will change your sign at the next step, which completely changes your answer. So over here for my solution space, I'm going to write my two answers, which are 8 and -1. All right. The next question I'm doing, you probably don't have in your packet, so I know I don't have it in mine. So I'm going to add a new page to this, and I want you guys to double check to see if you have this in your packet. So for this example, I'm going to write out the square root of x minus 2 equals the square root of x minus 10. If you don't have that question in your packet, please add this in on the back of one of your pages. Mia, this looks disgusting. What do I do? Okay, good. I'm glad you said square first. Guys, one thing I do not want you to do, don't move this radical to the other side. When you have two radicals on either side of your equation, so one on the left, one on the right, don't try to move both radicals to both sides. Leave them where they are, and then we're going to square both sides. Mia, when you do that, what do you need to do on this left-hand side? What do you have to do? You have to FOIL it. So this part here, we're going to have to FOIL. So we're going to make this a square root of x minus 2 times the square root of x minus 2. And we're going to set it equal to, what's the square root of x minus 10 squared? X minus 10, the radical cancels. So we're going to have just x minus 10. The fun part for this question is actually foiling. So let me go through how to foil this with you guys. And maybe, who knows, maybe Mia can do this for me. Mia, if you're foiling, what's the square root of x times the square root of x? Just x, because when you multiply x times x, what do you get?
Wait, sorry, x times x to the square.
There you go. So I'm going to leave it as just right now x squared, but it does simplify to x, so you are right. I just want to write it every single step. Square root of x times negative 2 is what?
Negative 2 square root x.
Perfect. Enter.
Negative 2 square root x.
And last.
Positive 4.
Guys, it's just regular foiling. We're just adding a radical. Mia, can I combine anything here? Can I combine anything?
2x squared.
What do you mean the 2 squared?
2 square root x.
Both of these. Okay. And then you told me at the beginning that you can simplify? You could simplify the square root of x squared, right?
Yes.
Which is just going to be x. What's negative 2 square root x minus 2 square root x?
Negative 4 square root x.
Notice that she didn't say x squared, guys. It's just negative 4 square root x. Plus 4 equals x minus 10. Guys, this is just a regular equation. I do see that I have another radical here, so I'm probably going to need to move just the x and the 4 to the other side of your equation, both of them. When I do that, I'm going to subtract x on each side, and I'm going to subtract 4. The x's here cancel. The 4's cancel. On the right-hand side, what happens to the x's? They cancel, and I'm left with negative 14. We're doing the same thing that we've already done, guys. All I need to do from here is try to figure out how to simplify this. There's 2 ways you could do this, so look up for just a second. We can divide both sides by negative 4, or we could do what instead? Or we could square. Let's just think about it. With that 14 being squared, what do you know off the top of your head what 14 squared is? I was like, if you do, you can write it out, but I personally don't want to have to multiply it. So we're going to go ahead and divide both sides by negative 4. This is going to leave me with the square root of x equals, when you reduce negative over negative, it's going to turn into a positive. 14 over 4 is going to reduce to 7 over 2. Okay, from here we can square both sides. So x is going to equal 49 over 4. You're literally just squaring the numerator and denominator. Okay, we need to think about this. If I have 49 over 4, I still need to do the check step. And I know it sucks, guys. I know you don't want to, but you have to check it. If you don't check it, you're risking losing points on your tests and quizzes. So over here to the side, I'm going to go ahead and do my check step. And with my check step, I'm going to use the original formula. So we have the square root of 49 over 4, which is your x, minus 2, equals the square root of 49 over 4 minus 10. So let's simplify. We have, okay, square root of 49 over 4. If you take the square root of 49 and the square root of 4, you will get 7 over 2. So this will be 7 over 2 minus 2 equals the square root of, if you take 49 over 4 and try to subtract it from 10, well, you have to find a common denominator first. So that's going to have to be 4 for the denominator. So this will be 40 over 4. Okay, well, I'm going to have to do another thing as well. On the left-hand side, I need to make sure that I can actually subtract both of these without a calculator. So we're going to put this over 1, and I'm going to multiply it by 2, so I can have a common denominator. So we'll make the 7 over 2 minus 4 over 2 equals the square root of 49 minus 40 is 9 over 4. Once I have that, I'm just going to simplify. So 7 minus 4 is going to give me 3. Whoops. This should be a 2, not a 3. This should be 3 over 2 equals the square root of square root of 9 is 3, and the square root of 4 is 2. So 3 over 2. Notice that both sides of this are the same. That means, let me zoom out, that 49 over 4 is your only solution. That should be your answer. All right, we're going to look at one last question. So let's see, we've done question 10. Let's go ahead and look at question 13. If you think you know what you're doing, you can definitely pause the video right now and start working on it. If not, we'll do it together. All right, well, let's think about this. I have 2 radicals on either side of my equation. If we think back to what we just did on the last question, we're probably going to need to square to start off, We're going to need to square both sides. So once we do that, I'm going to go ahead and think about the square root of 3x plus 4. Well, if I'm square rooting that and squaring it, all of this is acting as one big term. It's all underneath the radical. All of this radical is considered one big term. So what that means is I could just cancel out the square root and the squared. That's going to leave you with 3x plus 4. We're going to set that equal to, zoom in a little bit. If I look at this side over here, this is one big term, this is another term. So this is two terms on the right-hand side. So unfortunately, I know you guys don't like doing it, but you're going to have to FOIL. So we're going to take the square root of x plus 1 plus 1. We're going to multiply it by the square root of x plus 1 plus 1 again. Let me show you how to FOIL this side so you don't make a mistake. We'll recopy 3x plus 4 equals, okay, I'm going to distribute. This times this is the exact same thing, and don't rewrite this, guys, but this is the same thing as x plus 1 squared, because you're multiplying the same thing 2 times. So if you think about what we just did over here, we can just cancel out the square root and the squared, which will just leave x plus 1 with no radical. Sorry, let me write that in green. X plus 1 with no radical. For the next term, we're going to multiply square root of x plus 1 times 1, which is just going to turn into the square root of x plus 1. Inner will be, again, plus square root of x plus 1. And then for my last term, 1 times 1 is not 2, it's just 1. Now I need to combine my like terms. Be careful here, guys. First thing I need to combine are the 1's, so just these two 1's in the middle and end. And I'm also going to need to combine both of these radicals. Both of these radicals are acting as y plus y. It's the exact same thing. All of this radical is acting as one big, kind of like variable. We talked about this when we did adding and subtracting expressions a couple days ago. So to refresh your memory just a second, if you look back at adding and subtracting radicals, we do not change the radical or the index. We don't change the index or the radical, or radicand, excuse me. We keep it the same and we just combine your like terms. So we're going to do the same thing for this question. So on this part, all I'm going to do, let me zoom back in. We are going to combine the coefficients in front of both of these radicals, which are a 1. And I'm going to rewrite my answer. We're going to have 3x plus 4 equals x. The orange numbers we're going to combine to make 2. And then the coefficients in red, 1 plus 1, will give you 2 square root of x plus 1. Okay, well, let's kind of simplify this a little bit. Keep in mind, this 2 is attached to this radical by multiplication, so you can't touch that right now. What I can do is I can move the x and I'll move the 2. Not the 2 that's attached to the radical, but the 2 that's next to it. So we're going to have 2x plus 2 equals 2 square root of x plus 1. Keep in mind, this radical has that 1 underneath, so make sure you include that. Okay, well, there's a couple things we can do. Remember, we're at another checkpoint. We can either square both sides of this, or we can divide both sides by 2 and then square. Let's think. If I divide this by 2, this by 2, this by 2, you can cancel all those numbers. You can reduce them. So let's go ahead and divide this whole thing by 2. All 3 of these things will be divided by 2. The 2's here will cancel. And technically, when I say that the 2's here will cancel, it doesn't just go away. It has to reduce to something. Same thing here. The 2's do cancel, not technically go away 100% to 0, but you do need to reduce it. So 2 over 2 is just 1x. 2 divided by 2 is just 1, and that's going to equal the square root of x plus 1. Just like we did earlier, we're going to have to do another squaring again. So let me go ahead and square both sides of this. And unfortunately, we're going to have to FOIL one more time. We're going to have to multiply x plus 1 times x plus 1 and set it equal to, when you square something that's already being square rooted, you're going to cancel it. So let's go ahead and simplify. So I'm FOILing, even though I'm not drawing the arrows, I'm FOILing this. So we're going to make this x squared plus x plus x plus 1. I'm going to go ahead and combine my like terms in the middle. So x squared plus 2x plus 1 is going to equal x plus 1. We need to solve. So we'll have x squared plus x. Ooh, these ones also cancel. So that's going to equal 0. Guys, don't make this difficult. Think back to the beginning part of Algebra 1. When you have something like this, what would you do besides panic? You would need to factor out a GCF. So if you notice, both of the terms have an x. So let's factor out one x, which we'll leave in parentheses, x plus 1 equal to 0. This is extremely important because this x at the front is one of your solutions. The other x, you just have to solve. So one of the x's is my 0, that's one of your x-intercepts, or one of the x's, not x-intercepts necessarily. And the other x is going to be negative 1. Right now, you guys, not me, you guys need to check. Plug in both of those values and see if you will get the exact same number on each side. So right now, take both of those solutions and plug it into your original function, original equation. Double check your check step, guys. So for both of these, when you plugged in the 0, which was one of your solutions, and the negative 1 into every place that needed to be plugged in, you should have gotten 2 true statements. Both of those true statements mean that both of these answers, 0 and negative 1, they're both solutions. So that would be your answer. All right, guys, make sure that the questions that we did, they're easy, but make sure that you take time to actually learn and do the other questions that we didn't get a chance to do.